So, in this tutorial, we are going to talk about process versus threads. So, before to multi-threading, there used to be processes. When I say process means a very big process that has everything of its own. It's sharing nothing with the outside world. So, basically, processes are very heavy. While on other hand, when multi-threading came in picture, things changed because not everything was independent. There were few things that were shared, which we call sharing of the context. So the context was shared, some set of data was shared, and usually threads run within a process. So you could think of threads as a subset of process. So another thing that creating process is a heavy task, is a costly task, while threads are cheaper to create and are faster to execute and are more efficient. So I got one diagram that could demonstrate that to you. Yeah, this one. So here, if you see, this is a typical process, right? And this is our timeline. Threads are part of process and those execute on the timeline. So this thread executed, then because it has to either wait or finish, so this one is like waiting for some other thing. Then thread 2 actually took the processor and went ahead, and once this thread 2 finished up or fed up the CPU, thread 1 again started executing. They were like executing in series, but giving a feeling of like those are executing in parallel. So that's where actually threads are very efficient. Those utilize the CPU to maximum. And as of now, as of today, because CPUs got more cores, threading could be as efficient as we want. There are different flavors of threading. Not in Java. Like in Java, you will write the threads the same way that you are writing, but the CPU scheduling or time slicing, that could be a business of OS, and the OS could be very wise about that. Okay, I got one more diagram that I personally like a lot, and that is this one. Yeah, I like this beautifully. It has been organized. So if you see, we have got a main thread. So basically, in Java, when you run the application or you run a main method that is also a thread, it clearly demonstrates that. That's where we call it the main thread. So main thread starts and it go up till here, and it's either it's like in suspended state or resumed basically. So this one is like here it's suspense because thread 2 is starting and took up the CPU, but this is not something necessary that this always happens. There could be a possibility that it just calls the start method and moves on, right? Like main method could be executing and it actually starts thread 3 as well, but thread 2 and 3 haven't still not started executing. Those could start the execution at any point of time, we don't know. But this example is like one example where we are saying, okay, when main thread executed up till here, so here, and thread 2 actually started to execute and finished up at this point. And thread 3 actually picked up from the same point and utilized the CPU and went up till here. But here it got suspended and main thread actually finished up. So main thread has finished, right? But our thread is still running and it resumed from here and here it again waited and then finished up. So that's actually the threading is. That's where I was saying that it seems easy, but it is not. This is one snapshot. How timeline could look. There could be another snapshot as well. where main thread actually finishes executing and then thread 2 and 3 are executing in background, right? So that's the basic difference between a process and thread, and a little bit of talk about how when we deal with threads processing is done, right? So I can in next tutorial talk about thread life cycle or how to create a thread. So I'm thinking to discuss how to create a thread in Java native and then come to thread lifecycle. So that's what we will discuss in next tutorial. So thanks for this one. Stay tuned.